Okay, this question again, it's another theoretical one, no context. It's just about formulae, notation. Do you understand what's going on? So, I'm going to write down, first of all, what I got in the question. The first bit of information is a probability R given S. Now, that I know is 0.5. What does your conditional probability formula say that's equal to? How would you work out the probability of R given S? It's something over something. What will that one be from what we just did a minute ago? A formula you should now have highlighted in your notes.
Probability of R and S.
Yep.
Take over probability of...
Yeah, okay. So, now from looking at what I've written down there in that box, are we told in the question any information that I don't yet have as a number?
PS equals point...
Yeah, okay. I know that the probability of S is 0.6. So from there I have that 0.5 is the probability of R intersection S over 0.6. So I can rearrange that. What do I need to do to find the probability then of R and S?
Times them.
Yeah, times those together. Okay, half of 0.6. What's half of 0.6? 0.3. So, that is a very useful bit of information that I have already pulled out of here. Now, I'm going back to the start of my question. I have dealt with that bit there. Now I'm going to look at this next bit here. It told me the probability of R given not S was equal to 0.4. I'm going to do just what I did earlier. And any time you're given these conditional ones in the question, I would always do this. I'd try and unpack them and find out something else from them. So what is the formula for R given not S? Alice, can you tell me this equivalent for this one down here, please?
P R slash S. And then P N.
Yep. Well, that goes in here. Yep. Next. Yep.
S dashing.
Yep.
Over P S with the dash.
Yeah, that's right. Okay. So, I've got this link here. Now, do I know any of these things which I haven't got numbers on?
You can find out probability of S dash thing.
Yeah, that probability of S dash is going to be 1 minus the probability of S. Probability of S I've already had, that was 0.6. So that bit there is going to be 0.4 S dash. So continuing from here, I have, just repeating what I did at the top, 0.4 is the probability of R and not S over the probability of 0.4. So I'm just going to bring my working out down here. What can I do now then to find out the probability of R and not S?
0.4 times 0.4.
Yeah, times 0.4 by 0.4. So that's 0.16. Okay, so there is another bit of information that would probably be very useful to me that I've extracted from the question. Even before, to be honest, I've read what the question is asking me to do. If I came across a question like this, which gave me conditional probabilities in the question, I would do this even before I read what the question was going to do, because you're guaranteed you're going to be needing to extract this other information. So I've used all three bits of the information in the question. So now let's look at what I'm needing to do in part A. Part A, I want the probability of R. Okay. Anybody have a strategy that think might be a good idea to use from here? I've got various different probabilities, I'm wanting to find other ones. What technique have we used successfully before?
Did you use the probability of R, take R probability of S, take probability of R intersecting S, because you know that.
Okay, so which one are you trying to use? You're using the one that links the R and the S and the intersection together.
Yeah.
There's something else in that formula as well. There's a fourth bit.
The union bit.
Have we got anything about the union?
No, but we're going to work that out.
We probably can work it out, yeah. We haven't got it at the moment, so we'd have to work it out. What would be a technique we could use to make working out of that easier? If we go down the road that Laura said. Venn diagram, yeah. So I would do a Venn diagram next to help us. And from the Venn diagram, we'll be able to get what Laura's after as well. Sorry, yeah. Okay. So I'm going to have an R, and I'm going to have an S. And let's just see what we can fill in. What's the most important thing to fill in first? I said before, the middle bit, which is R intersection S. We worked that out earlier. It's the first one I arrowed. I said that's going to be an important result. That's 0.3. Is there anything else I can fill in?
Can you put 0.3 in the right circle?
Over here?
Yeah.
Why can I put 0.3 in that one?
Because the probability of S is 0.6.
Yeah, and S has to be everything in here, yeah. So what do you add to 0.3 to get 0.6? 0.3. Yes, you can. Okay. Now, let's just go through here then. I have now used that number, okay, and I have used the 0.6 number from there. Is there anything else I have worked out that I haven't yet circled that I can use in this diagram? What about this one here that we arrowed? R and not S. 0.16. What is that? R, but not S. Which bit is that?
It's going to be that equal in the middle.
Isn't it just going to be in the left circle?
Yeah, just the left circle. It's in R, but it mustn't be in S. That is, this bit of R over here, not including that one. So you can just put that in there. And now, Laura, from that you can work out the union of R and S if you want to, just by adding those up. But for part A, we were just wanting to know the probability of R. Well, now we've done the Venn diagram, we can just read it off. R is just those two numbers there added together. It's a 0.16 plus the 0.3, so it's the 0.46. I'm going to continue this question in a separate video because I'm coming close to the time limit on a video.